Okay, in this lesson, we're going to focus on word problems for right triangles. And word problems for right triangles will talk about either having an angle of elevation or an angle of depression. So, first thing we're going to do is let's talk about what is the definition for an angle of elevation. Well, the angle of elevation is, let me click a pin, the upwards angle from the horizontal to a line of sight. So to kind of better help understand that definition, let's look at the picture off to the side. So on the picture off to the side, when we talk about angle of elevation, okay, you have to be on the horizontal, which the horizontal is considered like ground. So look at the dog. You will see the dog, and the dog is looking up at a bird in the tree. And so for the diagonal line that goes from the dog up to the top of the tree, that angle right there that it makes with the horizontal is what we call angle of elevation. Okay, so you just gotta remember, angle of elevation is the angle where you're looking upwards. Okay, angle of depression. Well, angle of depression is going to be the angle that's not upwards, but downwards. So it's the downward angle. Okay, and the downward angles, so what you have to do is you or the bird in our picture off to the side is up at the top, so it's up high and it's looking downward. So you have to basically draw in a nice little dashed line right here from the bird to make the horizontal. Okay, so that's the horizontal, and then the angle looking downward is on the outside of the right triangle. Okay, so angle of depression is the top angle that is on the outside of the right triangle. But good news to us, if you can remember some stuff from geometry, the angle of depression, so angle of depression is congruent, and remember, congruent means equal, to the angle of elevation. And if you could remember why, not that you have to know, but the main thing you have to know why is they are alternate interior angles, and alternate interior angles are congruent or equal. So really, the angle of depression is going to be the same as the angle of elevation. So hopefully you'll better understand that when we get to some actual word problems. So number one here, to help you with any of these word problems, I always think it's a great idea to make a visual picture. So right now it says we have a 100-foot cable that is stretched from a stake in the ground to the top of the pole. Okay, so the ground is going to be the bottom. So here's my stake at one end of the ground. And then I'm going to have a cable that's going to go all the way up to the top. So we're going to make a right triangle. So I got my stake, and then this is going to be my cable on this side, and my cable is 100. Angle of elevation is 57. So remember, angle of elevation is when I look up. So that means I'm going to be looking up from the stake to the top. So is everyone good with the bottom angle by the stake being 57? Our job then is to find the height of the pole. So this side over here is my pole. So I'm just going to use H for height. Now, the good news to solve this is we're still using our three trig ratios, sine, cosine, and tangent. So if you can remember our lovely little saying, which I'll put over here to the side, SOHCAHTOA. Okay, we still got to label the triangle. So if I look at the 57 degrees, H is across from it, so that makes it the opposite. 100 is across from 90 degrees, and anything across from 90 degrees is the hypotenuse. So if I look at my little saying, who has O and H next to each other, and hopefully everybody says, oh, that's the first three. So that means S is sine. So we're going to do sine of my angle, which is 57, equals opposite, which is H, over hypotenuse, which is 100. And then to get H by itself, I'm going to multiply both sides by 100. So 100 sine of 57. So now just use your calculator, type in 100, hit the sine button, 57, and you should come up with 83.9 if I round to the tenths. And then label, we are talking about a 100-foot cable, so the label is feet. And we're done. Okay, the second one says a sun cast a shadow, 35-foot shadow of a pine tree on the ground. Okay, so the shadow is going to go on the ground. So here's my ground, and 35 is going to be on the bottom of my ground. Okay, so I got a pine tree over here. So here's my pine tree. And I'm going to make my right triangle. The tree is 65 feet tall. So over here on the side, we're going to put in 65. What is the angle of elevation? So remember, the angle of elevation is the angle looking upwards. So I marked that bottom angle there. So let's figure out the two sides. 35 touches my angle, so that makes it the adjacent. 65 is across, so that makes it opposite. OA. So if you think OA on our little saying, that would be the last three letters. So we're going to do tangent of X, because I don't know my angle, but you can call it whatever you want, equals opposite, which is 65, over adjacent, which is 35. And then remember, whenever you're trying to find an angle, you can't just hit the tan button. You have to do the inverse. So do second tan, so inverse shows up. And then 65 divided by 35. And we get angle X to equal 61.7 degrees. Done. Okay, number 3. We have a 20-foot ladder leaning against a building. All right, so here's my building. Boom. I got a ladder leaning against it. And then here's my ground. My ladder is 20 feet, so I'm going to put 20 over there for my slanted ladder. The base of the ladder is 6 feet from the building, so that makes the bottom. So the bottom of my right triangle is 6. What is the angle of elevation? So remember, that's the angle looking up, so I'm going to mark it here. Okay, 6 touches my angle, so that's adjacent. 20 is across from my right angle, so that makes it the hypotenuse. Adjacent hypotenuse, you're going to say, oh, well, that's the middle 3 letters. So we're going to do cosine of X, because I don't know the angle, equals adjacent, which is 6, over hypotenuse, which is 20. And then remember, to find an angle, you have to do inverse. So hit second cosine of 6 divided by 20. And you will get angle X to equal 72.5. Now, this question also has a second part. So let's look at the second part. It says, how high does the ladder reach the building? Okay, so that means I'm looking for the height over here. So I put h in for my height. And I now know my angle is 72.5. So I'm going to use that angle. I'm going to use h, and it doesn't matter which side I use. Oh, actually, I don't even have to use that angle. Let's do something easier. Boom. Instead of doing a trig ratio, I can say, ooh, if I know two sides of a right triangle, I can use the Pythagorean theorem. So I would do 6 squared plus h squared equals 20 squared. So h squared would equal 20 squared minus 6 squared. So h squared equals 364. Square root both sides, and I get the height to be 19.1, and my label is feet. Now, like I said, you could have done a trig ratio and you would have gotten really close to the exact same answer. That's just a personal preference, whether you wanted to do that or the Pythagorean theorem. So number 4. Oh, we have a lighthouse. Okay, so here's going to be my lighthouse over here. And it says the lighthouse is 200 feet. Okay, and this time we're going to talk about angle of depression. So remember, for angle of depression, we have to make the horizontal line outside of the right triangle. So it's on the top, on the outside. So this angle is 23 degrees. But then you're going to say, what do I know about angle of depression and angle of elevation? They are congruent. So the bottom angle is also 23 degrees. We want to know how far is the ship from the base of the lighthouse. So I'm looking for x, the distance from the bottom part from the ship to the lighthouse. Okay. X touches my angle, so that makes it the adjacent side. 200 is across, so that makes it my opposite. Opposite and adjacent would be the last one. So we're going to start with tangent 23 degrees equals opposite, which is 200, over adjacent, which is x. If the variable's on the bottom of the fraction, we said the shortcut was to remember that meant division. So take 200 divided by tan of 23. And when I type that in my calculator, I get 471.2. And my label is feet. Okay, last one. You are standing 10 feet away from a tree, and you measure the angle of elevation to be 65 degrees. How tall is the tree, assuming you are 5 feet tall up to your eyes? Okay, so here's me. I'm a wonderful drawer, so here's my little stick figure. Okay, and then I'm looking up at a tree. So here's my wonderful little tree. So I'm looking upwards. Okay, so I'm not going to use the bottom of the ground. I'm going to use from my line of sight. So I'm drawing my right triangle in up here. So my angle is 65 degrees. We are 10 feet away from the tree, so that's going to be the bottom. And my job is to figure out how tall the tree is. So first, I'm going to have to find the height of from my eyes to the top of the tree. Okay, so I'm going to call this side over here X, or I'm sorry, H. I used H, not X. Okay, so 10 touches my angle, so that's adjacent. H is across from my angle, so that is the opposite. And once again, opposite adjacent is the tangent. So tan 65 equals H over 10. If the variable's on the top, you're going to multiply. So 10 tan 65. And I get that on my calculator to be 21.4. But that's not my final answer because that is just the height from where my eyes are to the top of the tree. What I have to then remember to do is to go back and put in, says, assuming you are 5 feet tall from your eyes. So I know from the ground to my eyes is 5 feet. So I have to take my height that I know and add 5 onto it to get from my eyes to the bottom of the ground. So I'm going to do 21.4 plus 5. So it gives me a grand total of 26.4 feet. And we're done.